Unit conversions. When we refer to something called a unit equation, we just mean an equation that relates two quantities that are equal. So we know a lot of these. 1 minute is equal to 60 seconds, right? 1 foot is equal to 12 inches. That's a unit equation. Those are awesome, but unit factors are more useful. A unit factor is the ratio of equivalent quantities. And so from this unit equation, we can make a unit factor. They're sometimes called conversion factors, and we use them to convert from one unit to another. They always come in pairs. That's because you can write them right side up or upside down. And which is which, it depends on your point of view. So look at the relationship between minutes and seconds. What would happen if I take and divide both sides by 1 minute? Is it still equal? Say yes. Yes, it is. It's an equation. A math equation is a little bit like a teeter-totter or a seesaw or a two-pan balance. And if you do something to one side, you have to do it to the other side to keep it level. As long as I do the same thing to both sides, I'm fine. Well, anything divided by itself is 1, right? So 1 minute over 1 minute is just 1. So this is a unit factor. The top equals the bottom. The numerator equals the denominator. 60 seconds equals 1 minute. If I multiply something by this unit factor, am I changing the value of the measurement by multiplying by 1? No. I'm just changing the unit that I'm expressing that quantity in. Well, if we have this one, we can also have the upside down of that, or the reciprocal as the math people call it. 1 minute over 60 seconds. So there's our 2 unit factors from the 1 unit equation. You take the unit equation, you put one side on the top, you put the other side on the bottom. And then you flip it over, and you've got 2 unit equations. Could I say 60 minutes per 1 second? No. Because 60 minutes does not equal 1 second. I have to keep the unit and the, that's the number. I have to keep the number and the unit together, right? So this is wrong. We recognize it with units that we're familiar with, like seconds and feet and stuff like that. But you get to micrometers and nanoseconds, and it doesn't really make a lot of sense necessarily, and so people do things that are just as silly as this. So just watch out. The unit and the number have to stay together. We can write metric unit factors by knowing what power of 10 those metric prefixes represent. So let's write the unit factors relating kilometers and meters. For this first one, let's start out with a unit equation. So put the pen on first. 1 kilometer. What does kilo mean? 1,000. I prefer to think of it in powers of 10 because we can do 1,000, but when we get 1/1,000th, it becomes messy. So kilo is 10 to the 3rd meters. Actually, let's do it this way. I need to leave a little space. 10 to the 3rd meters. Okay, so 1 kilometer. Kilo is an abbreviation, a nickname for 10 to the 3rd. So here I have the nickname times the unit. Here I have what it means times the unit. These two things are equal. So then I can make unit factors. I can put kilometer on top and meters on the bottom, or I can write it the other way around with meters on top and kilometers on the bottom. Okay? Because if we think about this guy right here, and think about canceling things out. Well, meter over meter is 1. 10 to the third is what kilo means, so those would cancel out, and I've just canceled out everything. It's a unit factor, it's equal to 1. Okay? Your book mentions, well, actually your book uses what I think of as a more advanced method, and I'm going to mention it here. I do not recommend this for students who are metric system challenged, okay? And you know who you are. For some people, the metric system just, I don't know, it just doesn't really make a lot of sense. If you are one of those people that has trouble with the metric system, don't do this. Plug your ears and go la 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 for just a minute. The text suggests writing the larger unit first and the smaller unit second, and then restating the relationship to eliminate negative exponents. So I'm going to tell you this once, and those of you who can do this will get it, and you won't need any further instruction. Come on, I want to draw. So let's think about nanometers. We'll do the relationship between nanometers and meters. Well, which unit is larger, meters or nanometers? Meters. So 1 meter is equal to, and then nano means 10 to the minus 9, right? So that means there must be 10 to the 9th nanometers in 1 meter. Some of you are like, yeah, of course. Fine. Great for you. Another example that might be a little easier to think about, centimeters and meters. What I'm teaching you is to say that 1 centimeter equals 10 to the minus 2, because that's what centi means, 10 to the minus 2 meters. And I'm going to be consistent in doing that throughout the class because I expect that probably at least half of you are metric system challenged. This more advanced method says to put the larger unit first and convert this to a positive exponent, which means you have to move it to the other side and you get 100 centimeters. Okay, so that's what I'm talking about. This is valid. It's fine. It's awesome. The problem is sometimes students get confused about which unit is larger, and they end up telling me that a centimeter is 100 meters. And that's like saying that a foot is 5,280 miles. It's not true. Okay? So if you're good with units, go ahead and do it that way. I'm not going to do it like that in class, though, because my experience has been that there's a lot of students that need a lot of help with the metric system, and that if we're really consistent in doing it this one way, it always works. So that's what I'm going to do. So enough of that.